Hi friends, welcome to my channel Interesting Engineering. In our forthcoming videos, we are going to discuss the topics in third chapter of the paper Electrical Measurements. So this third chapter covers various types of potentiometer. So in this video, we are going to discuss about DC potentiometer. So first, what's a potentiometer? Potentiometer is an instrument used to measure voltage by means of comparison with the known standard voltage source. It uses null deflection principle. So, we would have seen the potentiometer, which is nothing but a three-terminal device where we could connect a voltage source. So by means of this potentiometer, we could able to measure the value of unknown voltage by means of comparison principle, and it uses, while comparison, it checks for null deflection in the galvanometer. So this is the diagram of a DC potentiometer where we could see a slide wire. So this slide wire is made of platinum silver alloy, and over this slide wire there is a moment of sliding contact. So this sliding contact is made of copper silver gold alloy, and this sliding contact is the moment of the sliding contact is controlled by means of this null deflection in the galvanometer. So while moving the sliding contact over the slide wire, we check for null deflection in the galvanometer. And here, since it measures the voltage source by means of comparison with a known source, so here we have a known voltage source. So for measurement purpose, we need a unknown voltage source. So for our calibration purpose, we have one more voltage source over here. So this is the structure of a DC potentiometer, and here we have a rheostat. This rheostat is meant for adjusting the value of working current through the slide wire. So this is about the construction of a potentiometer, where the resistances in this potentiometer is made of manganese, and the slide wire is made of platinum silver alloy, and the sliding contact is made of copper gold silver alloy. So let's go back to the diagram to explain about its working. So here we have a double throw switch wherein the switch can be placed either in the calibrate or in the operate position. So as we all know, whenever we make use of any instrument, in the initial step, in the initial stage, we need to check for its accuracy. So to have a more accurate instrument, we need to calibrate that instrument first. So that is achieved by means of this calibrate position, where we provide a voltage of known value through the standard cell. So from this standard cell, we provide a constant voltage source, and here there is a battery. This to provide a known voltage source to the slide wire. So by means of this battery, the slide wire receives a working current. So this working current is adjusted by means of this rheostat position. So by varying the position of this rheostat, we can able to adjust the value of working current through the slide wire. So for calibration purpose, we need to pass two different voltage sources, and when these two voltage sources are of same value, the galvanometer will be showing a null deflection. So the sliding contacts position is placed at a single particular position, and this for that particular position, the value of working current is adjusted by means of rheostat. And this technique, this method of adjusting the value of working current for a particular value of sliding contact, that technique is called the standardization technique. So in calibration, we standardize this instrument for a particular value of working current. So with that working current, we will be measuring the value of unknown voltage source during its operating position. So when the switch is in the calibrate position, we calibrate this instrument, or we adjust the value of working current through the rheostat to achieve a null deflection in the galvanometer. So here we provide two different voltage sources, and when the value of these two voltage source becomes equal, so that is the value of voltage between the battery source and the potential drop across this sliding contact remains the same. At that position, the galvanometer shows null deflection. So that technique is called the standardization technique. So this is the first step of using this potentiometer instrument, so which is nothing but the calibration procedure. And after calibrating this instrument, we can able to measure the value of unknown EMF by placing this double throw switch in the operate position. So through this unknown EMF, we are providing an unknown potential. So this unknown potential, the current through the slide wire, that is the working current, is maintained constant. Once it's standardized, the value of working current will be maintained with the same value, and the unknown EMF is provided through this unknown source. And for the potential drop across this unknown EMF, when it becomes equal with the potential drop across this battery for a particular position of the sliding contact, we need to adjust the sliding contact position for the unknown EMF. When the position of when the galvanometer shows null deflection for a particular position of sliding contact, that represents the value of unknown EMF. So while adjusting the sliding contact over the slide wire for a particular value of working current, and by providing a voltage source through this unknown EMF, the potential drop across the sliding contact position is measured to find out the value of unknown EMF. So that's a measure of our unknown voltage. So by means of which we can able to measure the value of unknown EMF by comparing with the known battery source through this null deflection concept. So this is the working of a galvanometer. Is it clear? So once again I repeat, in the initial stage we are calibrating this potentiometer, and while calibrating we maintain a standard working current through the slide wire. So once it's calibrated, the working current is maintained constant, and then the position of sliding contact is adjusted for unknown EMF. While measuring the unknown EMF, the position of the sliding contact is being adjusted. So the potential drop across the sliding contact is being measured for a null deflection, and that potential drop is a representation of this value of unknown EMF. So this is the method to measure the value of unknown EMF by means of comparison technique using this DC potentiometer. So let's discuss about its advantages. So regarding its advantage, this instrument acquires less power, or it even doesn't acquire any power from the source, and since it uses null deflection principle, this instrument is more accurate. So these are all some of the advantages of using this potentiometer. So if you want notes, please text me. I will upload the notes of this potentiometer topic. So in our next video we shall discuss about the laboratory type potentiometer. So for more videos, keep watching. Thanks for watching. Please subscribe and share.